Next, we're going to talk about scaling, and we'll start again by scaling vertically. When we talk about scaling something, we talk about scaling it by a factor. And as that term suggests, when we scale, we're going to multiply. When we're scaling in the plane, we're going to scale relative to the x-axis or the y-axis or the origin. So what we're actually going to multiply is the relevant coordinate. To scale vertically, we'll multiply the y-coordinate by whatever our scaling factor is. So in this graph, h of x is the result of scaling f vertically by a factor of 3. So every point on the graph of h, its y-coordinate is 3 times the y-coordinate of the corresponding point on the graph of f. To obtain k, we're scaling vertically by a factor of 1/2. Every point on the graph of k, its y-coordinate is half that of the corresponding point on the graph of f. And you'll notice that the graph of h looks taller and more stretched out. The graph of k looks shorter and more squished. That's what we expect from scaling. The other thing you'll notice when we scale is that that point on the x-axis, nothing happens to it because it's already at 0. So multiplying it by anything, nothing changes. Okay, so again, we're going to look at this graph and look at what happens to the key points on the graph of f and see if we can figure out what's happening in the actual expression for these functions. So looking first at the graph of our original function f, we have -4, 2. So f of -4 is 2. We have 2, 4. So f of 2 is 4. And we have 5, -2. So f of 5 is -2. When we scale up to get h, we take every point and triple its y-coordinate. So -4, 2 becomes -4, 6. h of -4 is 6. 2, 4 becomes 2, 12. h of 2 is 12. And then 5, -2 becomes 5, -6. Right? -2 times 3 is -6. So our inputs stay the same, and our outputs are 3 times as big. It looks like we just take the output of f and multiply it by 3. The vertical stuff is totally straightforward again. Interesting. Let's see if this still works with the smaller scale factor. We're scaling now by a factor of 1/2, which means we're going to take each y-coordinate and multiply it by 1/2, which is the same as dividing by 2. So -4, 2, divide the y-coordinate by 2 and we get -4, 1. k of -4 is 1. 2, 4, divide the y-coordinate by 2 and we get 2, 2. k of 2 is 2. 5, -2, divide the y-coordinate by 2 and we get -1. k of 5 is -1. Again, we just took the output of f and took half of that. So we divided the y-coordinate by 2. We took half of the y-coordinate. Okay, so the vertical thing, straightforward again. If g is what we get by multiplying f by 1/c, then g is the result of scaling f vertically by 1/c. If g is what we get when we multiply f by just c itself, then g is what we get if we scale f vertically by a factor of c. The scale factor is the same as the number we're multiplying f by. Notice that we only talk about this for positive numbers. We'll see later on what goes on if we multiply by something negative. That's a little bit different. But multiplying by something outside the function does exactly what you think. Multiplying by something smaller than 1 squishes the graph. Multiplying by something bigger than 1 stretches out the graph.